Hello. I want to answer a couple of questions from the test prep. So here goes. And we'll go ahead and do this. Now, the questions are the following type. You have the 1 over 1 minus x. And let's say you wish to expand about x equals 5. Now, there's two methods of doing this sort of problem. The first method is algebra. Which I think is the easiest method. And I didn't really emphasize this in class that much, but I'll go ahead and do this now. The way to write this is that if you're going to expand this around x equal 5, you want to somehow write this. But instead of having an x, you want to have an x minus 5. And the reason is that this makes this powers of x minus 5. However, in the denominator, what you've done is you still have a 1 minus x that you do here. But in effect, what you've done to the denominator is you've added a negative 5. So you've actually added 5 to the denominator. So you have to subtract 5 so as not to change anything. Now this becomes 1 minus 5 is a minus 4 minus x minus 5. And you can check that this is correct because minus 4 minus a minus 5 is a plus 1 and minus x is that. Now to get this in the form we want, we can divide out by a negative 4 in the denominator. And what happens is that you now have a 1. Now this is minus, well, this becomes a plus x minus 5 over 4. Okay. Now the series itself, which the question did not ask for, but the series itself is now, well, we can rewrite this one more way. And there is now a negative inside here, the second negative. So this is negative 1/4 summation k equals 0 to infinity. And now we have this negative x minus 5 to the 4. All raised to the k power, which we can write like this. Now to find the interval of convergence, or to find the radius of convergence, we realize that this is a geometric series. So we realize that this x minus 5 over 4 has to be less than 1, which is x minus 5 less than 4, which is x minus 5. Removing the absolute values is between 4 and negative 4, which now moves to adding 5 to both sides. Which turns out to be 5, not 1. Got 2, and we just did that. So now we have a 1 x 9, and the radius equals 4. Okay, so that's how that was. Now, there's a second way of doing this, and I'll give you the second way. And for the second way, I'll do the other problem. But keep in mind, you can do either problem, both the same way. if you wanted to do 1 minus x about x equals 3, you could, if you so desired, try Taylor's method. And Taylor's method says this will be your f. And since we're going to do this around about 3, the series will be k equals 0 to infinity, the kth derivative of x with 3 plugged in, x minus 3 to the k over k factorial. That's Taylor's theorem here. So now we have to figure out what's going on here. Well, the 0th derivative is just plugging in 3, which is, you do that, you plug in 3, you get minus 2 to the minus 1, which is minus 1/2. The first derivative, well, negative 1 comes down, 1 minus x minus 2 times a negative 1. Because this is in here, this works out to be 1 minus x to the minus 2, and f prime of 3 is, which is really negative. That's going to be negative 2 to the minus 2 power, which is going to be 1/4. Now the fun starts. The second derivative. Negative 2 comes down, but you get a negative of negative 2. That's a positive 2. Well, I'm sorry. Negative 2 comes down. 1 minus x to the minus 3 times the negative 1, which works out to be 2. 1 minus x minus 3. And the second derivative with 3 plugged in is going to be negative, because you put a 3 in here, you get a negative 2. Negative 2 cubed is negative 8. So you get a minus 2 over 8. And the pattern continues, because the next derivative, the third one, well, you get a 3 times a 2. So that's a 3 factorial, 1 minus x, and I get a negative 4 times negative 1, so that we get that. So the third derivative with 3 plugged in is 3 factorial divided by 2 to the 4th, and so forth. So you do get an alternating series. So if you write the series this way, we see the pattern here. It's going to be it's going to be a k factorial. It is alternating, so it starts at negative 1 to the k plus 1, because it starts negative and keeps going. We now have a 2 times 2 to the k, and there's a reason I'm writing that 2 down here, 2 times 2 to the k, x minus 3 k over k factorial. Now, this way, if you notice, this and this cancels. We can take the half out. And then what we have right here is we have an x minus 3 over 2 all to the k. That's a series. This is now an alternating geometric series, or any geometric series. So this converges by that, or by the root test, for this less than 1, or x minus 3 between 1 and negative 1 over 2, that is. And we get negative 2 x minus 3 positive 2. So the radius is 2. And then if you add 3 to both sides, we get a 1 here. And we get a 5. So the radius is 2. Now notice this was a different way of doing this. You could have, so this was method 2 with Taylor's theorem, okay? Now you could have done algebra here. Algebra also works. So if you write this 1 over 1 minus, well, if you write a minus 3 here, that's the same thing as adding 3, so you better subtract 3. Then you better divide out by negative 2. But since you divide it out, by 2, you get a 2 here. So when this 2 comes multiplies, it cancels it out. So now, to find the interval of convergence, we now know that x minus 3 over 2 is between 1 and negative 1, and it's just like before. Add 3 to both sides, and we get 1. The radius equals 2. So it works the same way. Now, to be honest, this is not going to be on the test tomorrow, but it could be on the final. Okay, stop this.